All right, let's go ahead and get started. Hi, everyone. Welcome. Thank you all for being here. My name is James Sawyerwini. I am a software development engineer at Amazon Web Services. I work on the Python SDK for AWS, as well as the AWS command line interface, which is what I'm going to be talking about today. So we're going to look at advanced usage of the AWS CLI, but more generally, we're going to try to get a well-rounded view of the AWS CLI. So by advanced usage here, I don't just mean advanced features, though we will cover that, but I also mean we're going to try to look at common or core usage scenarios and really try to explore them. Ask ourselves, what else is there? What else do I need to know? What else can help me? Because the end goal of all of this is to try to make us more proficient at using the AWS CLI. The better we know the tools we use, the more productive we are. And so hopefully you can take some of the things we talk about today and incorporate them into your day-to-day usage of the AWS CLI. Now, I'm going to be talking about three broad categories here. If you're not familiar with the AWS CLI, that's OK. I'm going to give a quick, maybe 5-minute crash course introduction. And then we're going to cover some of the core common usage scenarios. And then finally, we'll look at some more advanced topics. Some of these are fairly new to the CLI, and we'll take a look at those. So the first thing I want to cover is a quick crash course into the AWS CLI. So if you've never heard of it before, the AWS CLI is a unified tool to manage your AWS services. And by that, I just mean you have a single tool that you install and you configure, and it gives you access to all the various AWS services. Now, we support 3 installation methods. There's an MSI installer for Windows, and then there's a zip file or a bundled installer that's cross-platform. And if there are any Python developers out here, the AWS CLI is written in Python. So it's just a Python package. And if you're familiar with pip, which is a tool to install Python packages, you just run pip install AWS CLI, and you can install the CLI. Now, once you've installed the CLI, to configure it, the easiest way is just to run this configure command. So you run AWS configure. It asks you a series of questions, and you answer them, and then you're all set up. Now, one of the things you'll notice when you start using the CLI is that there's a consistent calling pattern. So every command has a similar structure, and that is every command starts with AWS, and then you have a command and a subcommand. And generally, in the common case, a command is the service name, and then the subcommand is the operation name. So in this case, this is making a call to Amazon EC2's describe instances call. And if I wanted to make a call to another service, you're going to see that same calling pattern again. So that's how you can call the CLI. In terms of the output, there's 3 that you have here. By default, when you run a command, you'll get JSON output, which looks like this. There's also a text output. This is tab-separated columns. And then you'll also have a table output. And so depending on what your usage scenario is, you might pick one format over the other. You can override this on a per invocation basis or set this as a default. And so table output's good to visually parse JSON, really lets you have programmatic access if you have a JSON tool that can manipulate JSON. And then the text output's good for tab-separated output, or if you want to use grep or set or awk. Now, I know I went through that really fast, and I do want to mention that all of this is on our Getting Started guide, and there will be a link at the end. But to help solidify some of these contents, I want to go ahead and just switch to the terminal and give you a quick overview to help make sure we're all understand that basic scenario for the CLI usage. So I have the CLI installed. I've gone ahead and installed it. I just used pip, so I ran pip install AWS CLI. Oops. And one of the first things you'll do, as I mentioned, is you'll run configure. So I've already set this up, so I can just hit enter. But I would normally fill these out with the values that I want. And then when we want to make calls, it's that same calling format. So AWS, and then a command, which is a service name, and then say, for example, describe regions. And we'll have output here that's going to be the regions. Oops. Let's go ahead and switch to Wi-Fi here. So we would call describe regions, and we're going to see a JSON output. And once we see that JSON output, we're going to look at some of the other outputs we can see. So we're going to look at text as well as table. So if we go ahead and run this, we'll see that we have a JSON output, and so it has endpoints and region names. And then if I go ahead and add text output, this gives me that tab-separated output, so I can say things like, give me all the region names. And then finally here, there's a table output. And you can see here that this is just a little bit easier to visually parse. And there's two more things I want to cover for this basic crash course that we're going to see later on. And that's for any command, you can put help, and it will pull up a man page. So in this man page, you'll see things like description. You'll see all the arguments here. For some of the parameters, it'll give you a sample syntax here. So there's a shorthand syntax you can use or a JSON document. And then if we scroll down, there'll be examples for how to use the particular command in a number of scenarios. And then if we go all the way to the bottom, it'll document the output. So if you look at the output here, it'll tell you the keys and some documentation. So that's help. The other thing that we're going to run into is this part here. So notice I have public key material, and then I have this file : / excuse me. And this is basically saying instead of using this literal string file : / we're going to open the file, and whatever contents are in that file, we're going to use as that value. So I just want to mention that because we will see that later. So and this applies to any parameter. If, for example, I put ID RSA in a file, I could then reference it with temp and then the file name. So just something to keep in mind. So that was a quick introduction to the AWS CLI. I know that was quick, and there's more information on our user guide. But I want to now go over some of the more foundation or core scenarios you would run into when you use the AWS CLI. So the first thing we're going to look at is configuration. This is one of those things that every tool has. The AWS CLI is included. And we saw previously in the terminal that you just run AWS configure, you answer a bunch of questions, and everything's set up for you. But we want to try to explore and see what's really going on under the hood. And so probably less used is the fact that there are a suite of subcommands. And these subcommands, there's three in particular. List is good for helping you debug where your credentials or various config variables come from. And then there's also a get and a set command. I want to look at those two in detail. So if I run a command like this, get region, this is going to print the currently configured region I have to standard out. And so this is different from just the configure command in the sense that it's not prompting me for values. It's programmatic access. And so in a similar way, I can set values. Now, there's two things here that I'm showing with a set. The first thing is that I'm saying profile.prod.region. So this is saying set the region for the prod profile. And the second thing I'm showing here is profiles. And if you're a new user, a profile is just a set of configuration values. And you can imagine I might have a development profile that has credentials with access to specific resources, and I might have a production profile. And so the way you would normally use this is you can specify a profile argument to configure, and it's the same process, but it creates a new profile. I can then also append -- profile to any command I would run, and it'll run it with that profile that I specify. Now, one of the things that comes up fairly frequently, if you want to either back up these files or edit the files and try to understand what the configure command is doing, we actually write out to two files. There's this credentials file on the left, and then there's a config file. Now, the shared credentials file, you'll hear it commonly referred to as shared credentials file. It only contains credentials, so access key, secret key, and an optional session token. And the nice thing about this is, by default, the AWS CLI will write all the credentials to the shared credentials file. And other AWS SDKs understand this format. And so if you use the CLI to configure credentials, you'll now be configured in terms of credentials for the Python SDK, the Ruby SDK, JavaScript, Java, all the various languages we support. And the .aws/config file, that's used only by the CLI, and that has things that are CLI specific, things like what output format to use, the three that we looked at, or, for example, the region to configure that you want to use, say, US West 2. And the reason I want to highlight this is because the configure command understands all of this and handles the details for you. So, for example, if I were to run a command like we're going to set the access key, it will know first that that needs to go into the credentials file because it is a credential variable. And it'll also know that there's no section that exists. It'll also create the file if it doesn't exist. And so we'll write something out to the shared credentials file. Now, if I also then write the secret access key, it does the same thing. And I want to point out here also, when you set a command, when you set a configuration variable, it won't parse it and then rewrite out all the values. So if you have comments or a particular formatting or something that you like, it won't touch any of the existing lines. So in this scenario here, it would see that there's a profile defined for prod, and the next line's taken, and so we can write out the secret access key to this next line. And then just for completeness, the other questions you get asked in configure are the region, which goes in this section, and then the output, which gets added to this section. And notice here also it knows the difference between the two formats. The CLI has a slightly different format for profiles. That's because there are other sections you could have in the CLI that aren't profiles, so you have to denote profiles with that profile prefix. So if we bring this all together in an example, we might look at something where we want to create an IAM user, create credentials, and then have it configured with a new profile so we can use it in the AWS CLI. And so walking through this code, what happens here is we're going to first create a user, and then once we create that user, we're going to create credentials for it. By default, there are no credentials associated with the user. And we're going to look at this -- query thing in a little bit. But we grab the access key and the secret key. And then finally, we use that set command that we talked about to create a new profile. And so this allows you to create a new profile in the CLI entirely programmatically. And so takeaway here is that if you need programmatic access to your configuration values, definitely check out the AWS configure suite of subcommands. Now, the next thing that I want to talk about is query. One of the most common things you might do in the CLI is run a command, and then you'll get response back, but you only want a subset of that data. And so existing CLI users have hopefully seen this query option. We're going to cover some of the new things we've added. We've added a lot of capabilities that give you a lot more control over the data that you want. But if you're new to this and you haven't seen it, to give you an idea of what this does, this is a very high-level overview of what happens when you run AWS, EC2 describe instances or something, and you hit enter. And we'll parse the command. We'll create an HTTP request, and then we get a response back. And that's the part that I want to look at in more detail. So what we'll do first is we'll parse that response body, and then we apply this query expression. And then that query expression will then get sent to whatever the output renderer is, table, text, JSON, and then get printed to standard out. So to give you something more concrete, imagine that I have an AWS service response that has this XML body. We parse it internally into some Python data structure, so a dictionary of lists of Python types. And then from there, we look if a query has been applied. If a query has been applied, we then filter that data down, and then we figure out how we can actually get that to a table format, for example, if it was a table renderer. Now, as for the language itself, we use a language called JamesPath, and there's a site here, jamespath.org. It's a query language for JSON. And if you go over to the site here, it's kind of hard to see. It has a full specification for all the low-level details in the grammar if you're interested. And it also has a tutorial here. And you can click on this tutorial and go through it. It has interactive JavaScript widgets that kind of help you learn the language. And so updates as I type. Notice on the right-hand side, it updates as I'm typing. So it just gives you a lot more information about how you can actually learn the language. And it goes through all the various aspects here. And I do want to go over some of the syntax here, but that is a browser, and so we're in a CLI talk. So the most logical thing to do here is port it to the terminal, right? So I have, on the left-hand side, some sample input, and on the right-hand side, what that result will be. And I just want to give a quick tour of some of the things that we've added in addition to just some basic expressions here. So for example, if I give it a key name, notice here this common prefixes matches what this value is here. And so I can also index it and give it further keys so I can drill down. If you're familiar with Python at all, there's also, in addition to indexing elements here, you can also slice from the end, or index from the end of the list. So this is the last key, the next to last key. In addition, one of the things that comes up very frequently in the CLI is saying I want all the elements, but then I also, for each of those elements, want to grab the key name. So for example, I should mention this is a sample output for what an S3 list objects response might look like. So these contents are all the key names. And in addition, the two other things that come up fairly frequently are the ability to collect a subset. So say I want the key, the size, and maybe the owner ID. And notice I have a list of lists here. One thing you'll see in our examples is sometimes there's just this left and right bracket. And if you notice what happened there, we took that list of lists and flattened it down one level. And the reason I mentioned that is because a lot of times you'll just see, instead of star, you'll just see a left and a right bracket. That's just saying grab the list, flatten it down a level. And so it means if you keep traversing down, you'll always just have a single list. Now, the two other things that I want to show here are, first, I can create a hash. And these keys can be any name, so I'm going to call it maybe bytes. And then ID. And you can see here now I have a list of hashes here, and I can name the keys whatever I want. One other thing that I want to show here that we'll use in this next part is the ability to specify a literal string. So if I say, notice the backticks there, S3 object, every object has, or every key has now a type that has an S3 object. And you can notice here again, the key corresponds to the key, the bytes correspond to that size here. So there's the size there. And then ID is the owner ID. So these are common things that you might run into when you're making query expressions in the CLI. As far as some of the new things we've added, one of the things we've added is the ability to filter down your list based on an expression. So for example, if I wanted to grab all the objects where the size is, say, greater than 500, I can now do that. And let me go ahead and grab the size there. So we can see what this is doing is saying, I want the contents of this hash here, but I only want to filter them, and I only want the keys where this size here is greater than 500. So there's a lot of things that you can do for filters. In addition to greater than, less than, you have the typical, not equals and equals, all that kind of things. And another thing we've added are functions. So if I wanted to say, that I want to sum all my S3 objects, well, for this particular response, this has 10 plus 100 plus all the other sizes there. So I can use functions. And again, this is all in our tutorial, but I want to show one other example that comes up fairly frequently, and that's the ability to sort. So let's say I wanted to sort by, and I wanted to grab contents, and we'll keep our running example of where all the objects are greater than 500 bytes. And then from there, we're going to go ahead and sort it by the last modified date. And I'll go ahead and actually grab all the elements and then just print the key, the size, and the last modified. And so you can see here what we've done is we've taken all the keys, we made sure that they're greater than 500 bytes, but then we've ordered them by time. So notice 904, 919, 929, 1030. And this is using that sort by function. And that just gives an idea of some of the new things we've added to the language. And the reason that we're going over all this is because that language we just covered is that same thing that you can apply for a -- query option. So for example, if you actually take a list objects response and say maybe just 50, but then I give it that same expression we've been looking at, say maybe size greater than 1024, and we'll grab just the key and the size. And so we can see here we're grabbing the key and the size, and we can use the exact same language we were using for the query option. So that was an overview of the James Path language, some of the new things we've added. Again, I encourage you to check out the tutorial. It goes into a lot more detail. But I want to go on to the next topic, because one of the most common things you do in the CLI, in addition to filtering down your output, is invoking some sort of command and then polling and waiting until it reaches a particular state. So to give you a concrete example here, let's say that I'm running an EC2 instance. And so what I want to do, as soon as I launch it, it goes into a pending state, and it doesn't go into running right away. And if it's an EBS-backed instance, I can stop it, and in both cases, I can terminate the instance. But let's say I wanted to write a script where I launch an EC2 instance, and then I wait until it hits the running state, and then I do something else. And so if we have code that does this, it might look something like this. So we call run instances. We're now all familiar with the -- query syntax here. And then we get the state of the instance. And then finally, we just have a while loop where we poll until the instance is in the running state. So while it's not, we sleep for a little bit, and then we make a describe instances call, grab the state name, and we keep doing that. And This code seems reasonable. It's only 10 lines of code. It's not too bad. It's fairly straightforward. But there are a couple of issues with this code. The first is that there's no timeout. So notice in that while loop, it's entirely possible to get into an infinite loop. If, say, the instance never hits the running state, or it gets into the running state and something comes along and terminates it before we make that next describe call, you'll be sitting in an infinite loop. It also doesn't have any fail-fast failure states. So if I'm waiting for an instance to be running and I see it terminated, I know that I can break out of that while loop because even if I had timeouts, there's no point in waiting. It'll never go to the running state. And then finally, it is handwritten code. It's not a whole lot. To handle the entire edge cases we talked about, maybe it's double the lines of code, but it's still not too bad, but it's still handwritten code. And so in the CLI, there's a better way to do this. This is recently added, but you can use this wait command. And so it's still the same thing where you call run instances and you grab a set of instance IDs, but now you can use a wait command to block. So what will happen when I run this command, it will block and it will not exit until all of the instances are in a running state. And so the syntax here is the service name, so EC2, and then wait, and then the waiter name, which in this case is instance running, and then it supports all the arguments for that corresponding described instances call. Now, if you want more information on the various waiters available per services, you can use the help command. So that's the thing we looked at earlier in the talk. You can run AWS EC2 wait help, as well as AWS EC2 wait instance running help. And it'll give you a description of what query it's applying, what operation it's calling, and a lot more information on that. And one other thing I want to mention here is that because it corresponds to a describe call or whatever the polling call is to grab the status, in this case, with EC2, it's actually a batch call. So if I run describe instances, I give it a list of instance IDs, and it tells me the state name. So this also gives you another capability where if I were to call run instances and then say -- count 5, I can now call the same command and give it instance IDs with the 5 instance IDs, and it will block until all of those 5 instances are in the running state. And so it understands, it has the intelligence to understand about a list of results. It can also do fail-fast failure states with a list of results. So if any of those instances hit terminating, it will give you an error and say we weren't able to wait for all of them to hit the running state. So I encourage you to check that out if you are polling on resources now. And finally, I want to look at some advanced scenarios. So this is some of the new things we've added to the CLI. And the first thing here is templates. So to understand what templates are, we first need to look a little bit into what goes on within the CLI, particularly the fact that the AWS CLI is data-driven. And so by that I mean we have a JSON model that describes all of the inputs and all the outputs. So for example, and you don't need to understand the format of this model here, but what I do want to point out is that somewhere within this model, we can introspect it at runtime and map those to top-level parameters that we surface in the CLI. And because of that, it's also quite easy for us to accept alternate input formats. So for example, instead of having to specify each top-level parameter, it's actually fairly straightforward to just accept all the arguments from a single JSON document. You can imagine maybe you're sharing input and you'd like to just share a single file to show other people how you created a particular, say, Amazon EC2 instance. And you can now do this with the CLI. If you run --CLI input JSON, and this is that file // syntax we looked at earlier. Notice in this case it's a relative path, so it's just arguments.json. And instead of specifying all the other parameters, we just specify everything from a single file. And I think that's useful, but there's still more that we can do here. Because we have an input model that tells us exactly how the input structure needs to look like, it would also be great if it was possible to generate what that sample input looks like. And you can do that using this generate CLI skeleton. And what this will do is it will generate a sample JSON document of all the input, and then it will write that to standard out. I'm going to give you an example of what that looks like. So if I'm, say, using the DynamoDB create table command, you notice here in the help it has output, it has a description, it has a number of attributes here, or options, and it shows me what the sample syntax looks like. And so I could specify each of these one by one. But another thing I can do now is just run generate CLI Skeleton, and it will generate this JSON document for me. And so what I can do here, save it to a file, and go ahead and open that file. And notice here it has the structure of this file. It has all the input parameters and the correct nesting and all the names and everything correct. And so now I can just go through and fill in these values. So, for example, let's say I wanted to have two attributes, foo that's a string, bar that's a number. The table name maybe would be James test 1. And as for the schema, let's create a hash and a range key. So hash and a range key. And then perhaps, to keep it simple, we don't want any local secondary indexes, and we don't want any global secondary indexes. But we'll set the provision throughput to be 5 and 5. So you can see here, this is just an exercise of me going through and filling out the values. I didn't really have to worry about the structure or the key names. I just had to go and fill in the values that I wanted. So now, if I save this, I can instead specify an input JSON here to this file that we just provided. And if I make I'll go ahead and describe that table. So we can see here it has all the parameters I specified. Table name of James test 1, it has a foo and a bar attribute, it has a hash and a range key, it also has read capacity and write capacity of 5. So it has all the values that I needed, and I could do this all from a single JSON document. Now, one of the other things that I want to mention here is that while I've specified create table from a single JSON document, let's say someone sends me this JSON document and says, here's how I created this DynamoDB table. And I look at it, and I don't want to really edit the document, but I think this is useful. I want to create a table just like this, but instead, I want to specify a new table name. And so what I can do here is specify overrides. What will happen is it will load that baseline document from table.json, and then anything I've specified on the command line, it will apply as an override. So if I do this, and I describe that table again, you can see it's the exact same thing that I had created previously. I have foo and a bar, and I still have the same hash and range key as well as the provision throughput. But now I've overridden that table name. And so I can actually change this table name as well as any other of the top-level parameters that I want. And it makes it a lot easier for me to have this programmatic manipulation for input parameters. All right. All right, so that was creating and using JSON templates, something that, again, I encourage you to check out if you want to be able to generate these skeletons and make it very easy for you to fill in values. It makes it a lot easier for certain types of input parameters. So the next thing I want to cover is credential providers, and by that I just mean the mechanism in which we look up credentials. So when we go to make a request and we need to sign it, we go through this lookup process. You can imagine I might have a credential locator here on the left-hand side, and it's looking for credentials. So in turn, it asks each object, do you have credentials? And whichever one returns something, we go with those credentials. So for example, we ask the environment credential provider, do you have credentials? And if we're following our example where we ran the AWS configure command, we know that it goes in the shared credentials file, so the answer is no. And then it asks the shared credentials provider if you have credentials, and it says yes, it gives us credentials, and for the duration of the process, it uses those credentials. Now, the reason that I want to point this out is because you can see that it's possible to just have new credential providers inserted into this lookup process. And I want to go over one that was added fairly recently to the AWS CLI, and that's this assume role provider. Now, to help illustrate this point, we're going to look at an example where we want cross-account access using IAM Roles. And to show what's going on here, let's say that I have two accounts, two separate AWS accounts. One that has an S3 bucket in production that I would like access to, and then the other is a development account, and it has two IAM users shown here. And so what I'd like to do is give the IAM user on the bottom access to that S3 bucket. And so I could create long-term credentials from the IAM user in the production account and then securely transmit them and create a new profile using that script we saw earlier in the configuration section. But also what I can do is create an IAM role. And so an IAM role just has two components. You'll need to say who can assume the role, and once that person or thing has assumed the role, what permissions do they have? And so what we're going to do here is create a role and say that the developer or that IAM user on the bottom has access to this S3 bucket once it's assumed the role. And you would go through and you would normally set this up, but once you set this up, you still have, before the assume role provider, there's actually still a number of things you would have to do. So you would need to make a call to the AWS security token service saying you want to assume the role. And then it would check, make sure that you have access to or permissions to assume that role. And then if you do, it will give you a set of temporary credentials. And then those temporary credentials can then be used to assume the role. Now, before the assume role provider, you had to manage this yourself. And while you could script this quite easily, the other thing that makes this slightly complicated is the fact that these are temporary credentials, so they expire. So you'll need to make sure that in addition to creating a profile, you're also checking that the credentials haven't expired. And if they have expired, you need to make a new assume role call and then set those as your new configuration variables. And so you can now have this all automatically handled for you in the CLI. That's using these two configuration values here. So we're using the configure set command again. And I set the role ARN that I want to assume, and then I set a source profile. Now the source profile is pointing to another profile that has credentials, and that's because that initial assume role call is an authenticated call, so we still need credentials. So notice that dev is pointing to an existing profile somewhere. And once you set this up, it's just like normal usage of a profile. We will automatically handle assuming the role if there's no initial credentials, and then we will also cache those credentials. And then if you make that same call again, it will use the cache credentials until they expire. And once they're expired, it will automatically refresh it. It also handles a scenario where if you're running a long process, say an S3 sync or a copy with a lot of files, if the credentials expire mid-transfer, it will also reassume the role and grab a new set of credentials for you. And so I want to show what this looks like in the terminal here. So I went ahead and already set up a role here. And the first thing I did was I'm going to create a role, but I'm going to give it this policy document here. And this policy document just says that a particular user is allowed to assume this role. So I make this call here. And then I'm going to give it access to an S3 bucket. So this is just saying you can list and get the bucket location. You can do any operation within the bucket, and then you can also list all the buckets. And then I make this put role policy call. And notice I give it a policy name and then the document. And so once I've done that, it gives me the ability to assume the role. And so what I would need to do in the CLI is, again, run those two commands, the configure set commands. And so I've gone ahead and already set that up. And just to show you what this looks like here, this first one, prod access, notice I've set the role ARN, and I've set the source profile. And so now that I have this set, I can go ahead and run a command, and we'll look at what's going on a little more detail here. I'm also going to create a debug log. If you haven't seen this before, you can specify --debug, and it prints a lot of information that can help you troubleshoot any problems you might be running into. So I'm going to go ahead and save this and run this command. So what's happening here is it's going to assume the role, and then it's going to go ahead and reuse those temporary credentials to make the S3 call. And notice here we see the output of the bucket. And if we actually look at this debug log here, you can see two things happen. First, we're looking for credentials, so that's that credential provider we looked at a few slides ago. And then it notices that it's going to assume a role, so it retrieves the credentials via assume role. And then you can kind of see here, it's making a call to assume role with the appropriate parameters. And then it gets credentials back, and then it makes a call to S3, which is here. And notice it's, again, making a call to this particular S3 bucket. And so what's nice here is then if I run the same command again, when we look at the debug log, again, you see that I still have access to that S3 bucket. But this time, you'll see that it's assuming the role, the credentials are retrieved from the cache, and then it went ahead and made the S3 call. So that's using assume role. Again, it's just like any other profile that you've created, except it really gives you a lot of flexibility here. And there's one other thing that I want to cover, and that's this prod full S3 access. So in addition to the role R, and I've also created another role here, but notice this line at the end here, it has MFA serial. And so this is the ability, when you assume a role, to require that they also need to send a one-time password from an MFA device. And so what that looks like now is, if I go ahead and try to make a call here, in this case I'm just going to list all the buckets, and I specify this new profile, what's going to happen is it's going to see that it wants to assume the role, but that MFA is required, and so it'll actually prompt me for the MFA token here. And in this case, I actually have a virtual MFA device set up with my phone. So if I go to my phone, then I enter the MFA code here. It'll go ahead and make the assume role call with the appropriate parameters. And then if you notice, if I say list the contents of the other bucket, so this role has full access to anything in S3 in this prod account. And if I list the contents here, notice I'm not prompted again. It just gives me the access because it's using that cache credentials. All right. And so that was a look at the assume role provider. There's also another parameter I didn't show here. If you want to specify an external ID, you can also specify that. And that's just another thing you can add to a policy to require that that parameter is sent. That's using assume role provider. And the next thing I want to look at is Amazon S3 streaming. This one's just a thing that I think is not particularly advanced, but I think it can be useful. So what this allows you to do is, normally, if you run the S3 commands, something like CP, which allows you to upload, download, and copy from S3 to S3. But say that you want to avoid disk I/O. So one of the things you can do now is specify the dash. And so what this is going to say is, instead of reading from a particular file, stream from standard in. And so it has all this logic built in to read from standard in, also intelligently switch to multi-part upload if the file size or the stream gets large enough. So it handles all this for you. And it also allows you to stream to standard out. So I can say I want to take this S3 object and download it, but write the contents to standard out. And so it enables use cases like this, where I want to take something from an S3 bucket, maybe download it, compress it, and re-upload it. And let's say that it's a really large file and bigger than the space that I have locally available to me. And so I can use something like this, where I'm running the CP command. I'm taking it and streaming it to standard out, and then piping it into a command here, bzip2. This is just a command that compresses data. And then I'm taking that and streaming it directly back up to S3. And so this can handle a file of any size. It doesn't matter how large the file is. It'll just stream that from standard in to standard out. And it allows a lot of interesting scenarios where you don't necessarily need to write out temporary files. And so we're actually going to move on to a topic. This is kind of an extra thing here. I want to talk about Bodo Core for a couple of reasons. Bodo Core is a Python library that the CLI uses. And it's a thing that handles all the request serialization, response parsing, all of the credential management, all that stuff. And the CLI uses it, and it's meant as a building library, a building block library that other libraries can use. One other example is Bodo 3, which is the new version of the Python SDK for AWS. And I want to show this example for a couple of reasons. The main one is that if you've installed the CLI with pip, you already have this library available to you. And so if you want to start exploring what you can do in Python for accessing AWS, you can check out Bodo Core. And in this example here, we're creating a session. And once we create that session, we can create a client for any of the services. So in this example, I'm creating an S3 client. I'm then saying that I want it to be in the US West 2 region. And then in this case, yes, this is Python code, but hopefully it's not that hard to follow for the people who aren't Python developers here. But we're calling the list buckets method here. So every client has methods mapped to operations. So for S3, things like list buckets, list objects, get object, put object. So we're making that call. And then the data we get back is just a hash. So it's just like a Python dictionary. And so I can access the buckets key. I can iterate over it. For each bucket, it has a name. And so I'm printing out all the names of my buckets here. And just to show you what this looks like, again, if you've installed via pip, which in this example here I have, you have access to this already. So again, I can just type Python, and right away I can just start importing BodoCore and trying it out. So I can get a session, like we saw, and then I can create a client. So in this case, I'll create a DynamoDB client, and say for US West 2. And then I can call list tables. And I get a response back. And so this response has a number of keys, so I can say things like response table names. And it's just like accessing, say, a JSON document or so, where I can then index it and whatever else. So that's just an example I wanted to show you because it does come included if you've installed it, the CLI with pip. All right. And so those were all the topics that I wanted to cover. So just wrapping up here, we looked at configuration, looked at really what goes on when you run the configure command. We looked at waiters, and we looked at query, both some of the new things that have been added, and as well as waiters, which allow you to pull on resource changes. And then we looked at templates, which are a way for you to have a lot of programmatic manipulation over your inputs. And this new assume role provider, which makes cross-account access much easier with the CLI. And finally, an example of S3 streaming, as well as an extra topic on BodoCore. So here's some of those links I was talking about. The AWS CLI is fully open source, so we are on GitHub. Feel free to file issues or send pull requests. The library that I showed previously, BodoCore, is also on GitHub as well. There's a link to our user guide there that goes over all the details of getting set up and all the links for the MSI installers and anything else. So if you're a new user, that would be the link to check out. Then we also have links to the forums, our reference docs, and then that jamespath.org site. And finally, if that last section I covered, BodoCore, was interesting to anyone and you want to learn more about the options you have for Python development, using the Python SDK, there is a Bodo 3 talk tomorrow that I highly encourage you to check out. In addition to looking at this low-level client that we just looked at, it also goes over a higher-level object-oriented interface based on resources that's really nice to use. So I encourage you to check that out if you're interested. And once again, I want to thank you all for being here. It looks like we have a little bit of extra time for questions. I hope you all enjoy the rest of your conference. And once again, thank you.